Okay, we have a scenario here. So say a marketing team emails 100 customers. Historically, 5% convert into buyers. What is the probability of exactly 5 sales? If we look at this question, our N in this question, or let's say our trial, which is N in this question, will be 100, okay? Because say marketing team emails 100 customers, right? And he said historically 5% converts into buyers. So that will be our probability of success is 5%, right? And 5%, if we divide 5 by 100, that will give us like 0.05. It says, what is the probability of exactly 5 sales? So X, our successes will be 5 in this case. So because what is the probability of exactly 5 sales? Okay. To calculate this, we will now say equals binomial distribution, open parentheses. Our number of success is 5, which is in B3. You can see it, comma. Our number of trials is 100. Our probability is 0.05, comma. Then we want to return exact probability for 5 successes, right? So we are taking false. So close our parentheses and then hit enter. We are going to be getting this probability. Let's make this into proportion, right? So let me make this into a percentage. Our interpretation here of this is that there is an 18% chance of getting exactly 5 sales. So the second part of this question asks, what about at least 3 sales? Now we say at least, right? At least 3 conversions will be less than or equal to 2. It's basically the same thing like we look for a probability of 0, 1, and 2. Practically the same thing because you are looking at a 0 chance of success, 1 chance of success, and 2 chances of success. So that is what at least 3 means. If we calculate this for all of these down here, let's try something. Let's try it that way. We'll say equals binomial distribution. So now here, for this number of success, we are taking 0, which is the X here. So comma, our trial is still 100. Our probability is still 0.05. And our cumulative, we are using false. So because I would like to autofill this so that we don't impute this formula every time, let me lock this trial and probability. So I'll be locking it with F4 on our keyboard. All right. So I'll hit enter. Then autofill because it will pick all of this, right? If you check our formula now, you see that our success is now in 1 here. Then our success is now 2 here, okay? So let's calculate it using at least 3. Let's use true and see here. What you will have done directly is to calculate it this way, equals to binomial distribution. We said the number is 2, right? Because say at least. See here, we use 2, at least 3. We use 2, right? So say 2, right? Comma. The trial is 100, comma. The probability is 0.05, comma. And the cumulative, we want to say true. Close our parentheses and hit enter. We have 0.11826, okay? If we add this, will it give us the same thing? So let's try and see. Equals sum, open parentheses, and let's put this range and hit enter. You can see it gives us the same thing. Our second scenario is for a manufacturing quality control, and the scenario reads, a factory produces 200 widgets with a 2% defect rate. What is the probability of less than or equal to 5 defects? So that means from our scenario, our trial is 200, right? Because say a factory produces 200 widgets. Our probability is 2%, which is 0.02. Then say what is the probability of less than or equal to 5 defects? We are looking for the probability, say, from 0 to 5. So that is why we have success in X here as 0 to 5. So since we are looking for a cumulative false binomial distribution, open our parentheses. Our success rate here is 0 to 5. That means we can, since we are doing a cumulative, the 5 will be the maximum point. So we are going to put 5 here and we'll say comma. So the number of trials is 200, right? And it's in B1, comma. The probability is 0.02, which is in B2, we say comma. Our cumulative now we want to use true, okay? Because we want a cumulative distribution function. Like I explained earlier, we want a cumulative of 0, 1, 2, 3, 4, 5 through, okay? Close our parentheses and hit enter. So we have a probability now. So what is the interpretation of this result? That is to say that nearly all production, if we make this into proportions, right, about 78.7% of all of the productions will have 5 or fewer defects. What if the question reads, a factory produces 200 widgets with a 2% defect rate? What is the probability of greater than 10 defects? What we'll do now is to write the formula this way. Okay, let me write successes here. That is x here, we'll say greater than 10. Okay, so what we'll do in this case will be that we'll say equals 1 minus binomial distribution, open our parentheses. So we are using 10, right? Our trial is 200, our probability is 0.02. Our cumulative now is true because we are still looking for a cumulative. Okay, close the parentheses and hit enter. So we have our value here, our binomial distribution value here. So let's make this into a proportion as well. We basically have about the 0.3% chance of having higher than 10 defects. Okay, so you are basically saying that a catastrophic failure in manufacturing is virtually impossible. So let's go to the third and final case study we have. Okay, and that case study will be on call center staffing optimization. Okay, the scenario reads, a call center makes 50 calls daily. So our trial is 50 calls with a 15% success rate. So probability is 15%. So that will be 0.15, right? That is 15% divided by 100. The question continues, what is the probability of 5 to 8 successful conversion? Okay, what's the probability of 5 to 8 successful conversion? Our success is here, is x, we have 5 to 8. So we are going to be calculating it in a... So let me read the question again. The call center makes 50 calls daily with a 50% success rate. What is the probability of 5 to 8 successful conversions? Previously, our successes were a particular number or a number less than that number or less than equal to a number or greater than that number. But now we're having a success rate that is a range. So what we need to do is to use a different binomial distribution function, which in this case will be the binomial distribution function with the range. So open our parentheses now. So here we have trial, okay? The trials here is 50, right? Comma. So then after comma, we have the probability, which is 0.15. Then you can see after that, we have the number of success for 1. We have the number of success for 2, right? Which in our case, we say 5 to 8, right? So the first number will be 5, comma, and the second number will be 8. Okay, we close our parentheses. So we are good to go this way. So we hit enter now, and we can have our results. There is a 56% chance of 5 to 8 successes.